Okay, this is a sort of Viva thing for IMAT3404 Mobile Robotics. Stefan Bauer, student number P13186907. Good, right. Hopefully it's recording the right screen. For this, I will be demonstrating the robot that I have built on a couple of different maps, one of which is the default mine, and one of which is a map of my own devising. I am using a console command to run the simulation at roughly 5 times speed. So there we go, here is the map. I have implemented the 4 different behaviours required: avoidance, edge following, mapping and wandering. Okay, here we go. Okay, so the first thing you will notice is that instead of just using the console, I have built a little dashboard because I found that marginally easier. Right, now I should be able to, yeah, I have now turned off all the different behaviours. Avoiding collision obviously doesn't really do anything on its own because it is primarily a modifier that's placed on other behaviours in order to make the not crash into walls, which it usually does fairly effectively. You can see from the little red or black indicators that the other 2 behaviours are currently disabled. Edge following. I've now enabled edge following, and it will quietly, yeah, it should now start following the edges. This is a good time to note that, as you can see, I have implemented a full tile-based, chunk-based mapping solution. So these are these lines are delineating 5 meter by 5 meter chunks, each of which is mapped with a grid precision of 10 centimeters for a 50 by 50 set of tiles. These chunks are added dynamically, mapped dynamically, and the red is obstruction. The blue component of each pixel demonstrates that it's it's penalised for the robot is penalised for getting too close to walls. You'll note that, of course, the sonar is slightly imprecise, so it has a lot of these extra tiles that have been inaccurately described as being filled. You'll note that they are getting overwritten as being empty, so it has a certain amount of noise correction built in, which is good. You can see that the edge following is functioning fairly consistently. The edge following has 3 different sub-behaviours, as it were. So it takes the 2 parallel 90-degree beams on either side, and from those it calculates the angle relative to the nearest wall. It does the same again with the 2 beams just further out. So 50, I believe they're at 50 and 130 degrees, or minus 50 and minus 130 degrees. So it'll work out the angle from those, and then it will also work out the distance to the closest wall. And then it has essentially a separate PID controller for each. So I've implemented PID in a separate object, which the follow behavior has 3 of. Here we are. You can see follow has 3 different PID components: offset, parallel and wide component, and they are weighted such that the offset has a 30% weighting, and then the parallel and wide component have a 35% weighting. This is kind of, it's important because it means that it cuts corners much more closely than just using parallel, and obviously the distance is so that it maintains a sensible distance from the wall. I will blast, I just missed a corner, which would have been useful, but if I enable tracking hopefully what you'll see is that when it cuts convex corners, it does so kind of with a certain amount of advanced, yeah, it tries to take a racing line of some description. It's about to get itself stuck in, yeah, and this is a really cruel bit of map design, this concave, very sharp triangle. Right. Well, we shall perhaps restart this actually, because it would be nice to demonstrate the final behaviour, wander, which makes use of the green component that you can see on the map. Yeah, it'd be nice to demonstrate that separately. So let's just stop that. Let's put this in a decent spot to start with, so it's not getting started directly inside a corner. And here we go again. Now, the wander and mapping behavior. This makes use of sort of a kind of a flow field kind of thing, almost, where in every map tile has a traversal cost dependent on how full it is or how close it is to a wall. So filled obstacle pixels impose additional cost on nearby pixels dependent on how close they are. So if they're close enough that the robot would be colliding with them, then that obviously is quite a high cost. If it is close enough that the robot might not be able to turn around, that's a moderate cost, and there's a very slight cost for just getting too near walls at all. Oh, for heaven's sake. Yeah, it's not perfect, as you can probably see. And then what happens is this essentially detects every unexplored pixel that is bordering a known pixel, so around all the edges of all these, and from those it derives, yeah, it essentially flood fills a cost where every pixel, yeah, every unknown pixel gets added onto a queue, and it checks the start of the queue, and every pixel it takes off the queue, it checks each neighbouring pixel and checks whether or not adding its current traversal value, which obviously starts at 0 for edge pixels. It takes its traversal value and adds the traversal cost of that neighbouring pixel, and if the resulting value is less than the value the pixel already has, or if the pixel hasn't had a value set, then it replaces that. And this acts as a sort of flood fill, which creates a gradient, wherein pixels near unexplored terrain have a low value, which slowly ramps up to higher values, which are a long way away from anywhere unexplored. This, in addition, has a this has a weighting such that theoretically it weights unexplored areas that are closer to whatever the set map goal is. And then what happens is for the wander behavior, it simply takes the pixel that the robot is currently on and works out a gradient based on its neighbouring pixels. And then it tells the robot to go along that gradient after normalizing it. And theoretically, the robot essentially just runs downhill to the nearest, it treats it like a height map, runs downhill to the nearest unexplored area. In practice, there's kind of a lot of flaws with this approach. Some good things too, but quite a lot of flaws. I mean, fundamentally, I think the mapping solution is a good one. Obviously, if the map is infinite, it will take up infinite memory. But unlike a point-based approach, within a set map which the robot cannot escape, there is kind of a set maximum memory usage, which is good, because that avoids ending up in a thing where you can't run a simulation for an extended period of time without going into a memory overflow. The most major problem I've found is just that the resolution on the sonars is terrible, and they seem to have an awful lot of noise, as is clearly demonstrated on the map. I don't feel like that's an error on my part. That's my code functioning as intended. And as could be expected, it's simply that the sonars pick up a lot of incorrect readings. And as I said, I've done my best to kind of denoise the map as I go along by detecting that sonars are going through tiles that had been marked as empty. But even so, it just creates a horrible mess, and that's slightly annoying. There is a fundamental bug, I think, somewhere in here, wherein if you look at the map, you can see that the black triangle is where the robot is facing, fairly obviously, and the sort of brown triangle represents the slope, and it just doesn't seem to point in the right direction a lot of the time, which is kind of depressing, and the robot doesn't seem to follow it very effectively, which is also sort of depressing. I honestly don't know what I'm doing wrong with a lot of this stuff, which is sort of sad. But on the other hand, it does work most of the time, and it only occasionally crashes into walls. And the edge follow works very well when I'm not mucking up with the wandering. So that's cool. And as you can see from the gradient, it does theoretically work in that the mapping effectively identifies unknown areas and then creates gradients down to them. It's just getting the robot to follow the gradients is harder than I had initially anticipated. I don't know, there's a lot else for me to say in this Viva. The full code is available, will be available to whoever's watching this probably. I mean, there's quite a lot of it. The mapping in particular is at least a good 1,000 lines of code, I would have thought. Coming up on 1,000. Because I had to build quite a bit of infrastructure for the full chunk-based system, which is yeah, I mean, it's basically a couple of decks with a custom data holder which has a pointer to another custom data chunk which has a big array of yet more custom objects. So you've got tile objects in an array inside a chunk, a pointer to which is held inside a chunk slot, which is how we have kind of uneven, chunks that aren't taken even inside the grid, so that it won't spawn unused chunks inside the map as a total. The thing I found moderately interesting is that I essentially relied on a system whereby I built in functions which just allowed you to navigate left, right, up and down, and then I just used those for everything, for all tile-based navigation, for setting up setting up areas of effect for the walls, for example. Setting up the comparative gradients was quite challenging, actually. That all works quite well. The only other thing that was really at all interesting was handling the multi-threading, because obviously using decks with that could be quite a problem, because if you don't account for it, then the decks may change size in the middle of something else using them, kind of race conditions, which is really bad. So I ended up building a kind of a globals data structure which has a couple of mutexes in, and essentially I lock the mutex whenever I'm editing the actual map, not the individual tiles, because that doesn't matter so much. After all, the only other thing that's really accessing them is kind of read-only. But if I'm ever editing the actual fundamental deck, so I'm changing the size of the decks, then I lock and unlock the mutex before editing it, or before and after editing it. Right, I've really run out of things to say. It kind of... Oh, I guess I should probably show off the mine a bit. The robot is very steadfastly dedicated to not doing what I want, despite my having done a lot of work to make it do what I want. Right, here's the mine, and probably what will now happen is it will go into the mine a bit and then turn around and decide to go and explore in the opposite direction, because that's what's happened every previous time. Yep, so it starts off quite well, it heads into the mine, it's riding the gradient down, so into new unexplored areas. That's all kind of working. Follow edge gets toggled on and off, so if follow edge if it's pointing in kind of the right direction, it'll toggle follow edge on. So while it's riding the gradient towards unknown areas, it will kind of follow walls a bit. But as soon as it starts pointing too far, well, yeah, outside the kind of a 60-degree angle in the right direction, then it'll override that and just kind of run in the right direction. And then the avoid will kick in whenever it starts to hit a wall. It's not really very sophisticated, the actual navigation. Right, and at this point it just kind of gets confused, and I don't understand why or what's happening. Because the slope is going in the right direction, and the robot, as you can see, Wander is giving it a delta heading to go towards the right direction, and it just bloody doesn't do it. You know, I'm setting the delta headings correctly. I'm fairly certain I am certain I'm setting the delta headings correctly. The Wander behavior is toggling to active, and a lot of the time the robot just doesn't seem to, follow the delta headings very effectively. And I can't work out if that's some built-in noise inside the simulator. I have no idea what's going on here, actually, because it's doing the full-on kind of wiggling, which it shouldn't, because I've got a full PID controller on the Wander heading. It's not. I'm not just feeding the raw delta heading straight in. I am feeding that through a PID controller. Same for the speed, and it just gets a bit rickety. That said, it's doing better than it sometimes does. It's at least got to the third layer without turning around and going completely the wrong direction. Now, this is one thing I've had quite a lot of problems with. Is again the sensor data just gets really gets really rough around these very small gaps. So quite often it will believe, because of the sensor noise, it will believe that these gaps have been completely blocked off when they haven't. Oh, that's good. That's good. Oh, maybe this time when I'm on camera it will actually show up as a success. This is excellent. Oh, go on, go towards the exit. Yeah, I've spent a lot of time sitting here chipping my... Why? Why is it It's not following the... Oh, God. Oh, yes, I see, because because for some reason it hasn't mapped this area despite seeing it. Oh, no, that's just because it only updates the... Yeah, because for performance purposes, it only updates the flood fill map kind of at slow intervals. So every 5 seconds roughly, but it feels slower than that. Right, this honestly feels like it might actually complete the map, which is cool. There we go. Go on. Oh boy. Yeah. One thing I've really noticed is that this tracking completely tanks the simulation performance. So this average sim real time started at about 5, and it's gone all the way down to just over 1. Anyway, as you can see here, the robot has navigated the mine. Right, I'm going to call this done because I am knackered and I have another assignment to do, and I have demonstrated that it works sometimes. Inconsistently. I tried. Yeah, and I mostly succeeded.